welcome.
Thank you. So here comes the showstopper, security. Uh, my name is Shahid, and I have been working at SICS since 2008. Recently, I have given the responsibility of security lab at SICS. Today, I'll talk about the cybersecurity in the era of IoT and cloud. Because of time limitations, I'll focus on one specific research item we have done, but I'll give you a quick overview of the lab. It's great to see that we are the best in everything. So cybersecurity, it's the biggest cybersecurity group in Sweden, the SICS Security Lab. We are 19 members, 2 affiliates, and we are in 2 locations, Stockholm and Lund. And when it comes to research, we work on different topics: basic research or disciplinary research, system research, and also very much application-oriented research. These are some of the keywords where we work with. Am I clicking here? Here. Core of our research, I would say, or the main topic where we work on is IoT security, cloud security, I would say cryptography, a lot of it, and many more. So if I categorize my lab's core expertise, it falls in these 6 categories: IoT, 5G, software, cloud, and privacy and blockchain. I'll come back to this in the last slide, but today I'll talk about one of these. So our research is funded by many Swedish and European projects. And today I'll talk about one item, which is Internet of Things. That's my personal research area, and that's what I know the most. So before I go to the security, Internet of Things is a network of globally identifiable physical objects. And there are some unique characteristics that Internet of Things have that makes it different from the rest of the networks. And these are most IoT devices. When we talk about 50 billion devices or 26 billion devices, they are resource-constrained devices. And they are deployed in networks where the networks are lossy, that we can't expect a continuous connection between these devices all the time. Sometimes these devices they have a short range, so they route data on behalf of other devices. And they are deployed in unattended environments, which means there is not always a user behind an IoT device, and there are no interfaces either. And they are extremely heterogeneous. When we say IoT device today, though we focus mostly on resource-constrained devices, it covers a wide range of devices. An IoT device can be a sensor, which runs on batteries for 10 years, 20 years. It can be a refrigerator, it can be a TV, it can be a car, it can be anything which is not a general-purpose computer is an IoT device. So one of the technologies, enabling technology behind IoT is IPv6. But IPv6 is there for more than 2 decades. Why there is so much hype today about IoT? And I think it was around 2007 and 2008 when IETF, Internet Engineering Task Force, the organization who has standardized the Internet protocol, they came together and they said, let's have IP in extremely resource-constrained devices. And they developed a protocol called 6LoWPAN. 6LoWPAN is nothing, but it's a compressed version of IP when it comes to resource-constrained devices. And from then onwards, we have so many applications, we have so many players who jumped into the IoT space. But still, the basic protocols are still coming from IETF, Internet Engineering Task Force, the organization who has built the Internet protocols. So this is a picture of an IoT network, I would say. You can draw many pictures. We have, here. So we have a network of resource-constrained devices. In IoT world, it's called 6LoWPAN network. We connect it with the internet through IPv6 communication. And when we are in this part of the network, we use a compressed form of IPv6. So for so good, we can use this architecture to build enormous applications. Now, potentially, we can connect any physical object by embedding a small microprocessor in it with the internet. However, the actual reality is a bit different when it comes to security, and that's my talk. State of the IoT security today is like it was in IT security in 1980s. There was hype on the internet, and vendors just rushed into the market to bring their products into the market without caring about security. And this is the state for IoT today as well. And this is one of the main reasons. Every next day, we hear in news, IoT is broken, my thermostat is broken, and it was, I think, 21st of October last year when the biggest IoT security hack was disclosed in the form of a Mirai attack that has downed the internet for hours. And when it was the biggest IoT hack, and it's one eye-opener, when big sites like Amazon, Spotify, you name it, they were down for hours by an attack, by a network of IoT devices. This was called Mirai attack, by the way. But as I said, the main reason IoT is broken today is people are just rushing into the market without caring about security. But I would say now we are in the stage when we really seriously thinking about security, especially a push from the Swedish government, I would say, EU, and other society in general. So SICS, since 2010, we have been working on IoT security, and we have developed so many protocols. I will highlight very quickly something here which you can use today in your product and services, and then I will give you some future directions as well. So I think most of us are familiar with this stack. This is a typical stack in an internet host. Some of you might have seen this. All these jargon here, they are IETF standards. They are the protocols which are already standardized by IETF to use in IoT devices. And we can connect these two worlds using a compressed form or a lightweight form of all these protocols to keep end-to-end security. I'll continue this with this picture. If you are an IoT service or product provider and you think about security, usually we have two ways to provide security, something which is called end-to-end and something which is called hop by hop. By end-to-end security, by hop security, we mean if you send something from source to destination, all parties in the middle, intermediate parties, they can see the contents of the message. On the other hand, when we have end-to-end security, there is an end-to-end trust between the sender and the receiver, and no one in the middle is trusted. And today we have protocols which are tailored or primarily designed for IoT devices, and you can run them in battery-powered devices and keep the battery life more than 5 years. And I highlight those protocols. One of them is called OSCOAP. It's called Object Security Protocol. It's an adapted IETF standard. And SICS have worked on this standard together with Ericsson for over 3 years now, and it's close to be a standard. And the other one is the CoAP S, or Secure CoAP. It is very similar to when you use internet, you say HTTP plus TLS, it becomes HTTPS. We can use today something like CoAP plus datagram TLS, and then you can make CoAP S. And as I said, it's a standard now. This URI is available now, and there are a lot of implementations. There's another possibility which is ready, implemented, tested, and evaluated is the IPsec, the Internet Security Protocol. We are familiar with IPsec when it comes to VPNs, connecting different organizations together. But IPsec has a little used, I would say, mechanism called transport mode, where you can have end-to-end security, where you have end-to-end security between two machines using IPsec. And there are open source implementations available that you can use. And the last but not least is the link layer security. We are all using Wi-Fi, and the Wi-Fi security is link layer security. or per hop security. It's just between your device and the router. And after that, there is no security if you only rely on Wi-Fi or link layer security. So to summarize this whole thing, if your requirement is to use end-to-end security between two data items, you go for OS GoApp. And this is the lightest protocol, I would say. If your requirement is to go for between two applications, go for transport layer security or DTLS. This is a standard now. If your requirement is to protect two machines and also the IP headers and IP packets to save against or guard against the IP spoofing attacks, which is one of the main attacks that leads to the DOS attacks, then go for IPsec. And if you want to just secure the two links, if you don't have a multi-hop network and you have other security mechanisms, you can go for link layer security. I'm not educating here which security mechanism is good or bad. It's up to you. The message here is we have protocols standardized, available, and implemented. And this is what we have been doing for the last 7 years. It's not so easy to run IPsec in an IoT device and get a better performance, and this node will be running on batteries for 5 to 10 years. So it was very challenging. Yeah, so these three first protocols, they give you end-to-end security between machines, applications, and data items, and between two links or between two hops. So this was what is available today and what we have been working on, and what you can really get it and use it. I'll show you one more slide where you can find what. But these are the three things which we think nowadays is really something which is missing. And in all these protocols and previous work, we have been using something called pre-shared keys or symmetric cryptography only. This can scale well if you have a limited network with few nodes, but definitely not for billions of IoT devices, which are heterogeneous and deployed in harsh environments. And I'll talk a bit about identity as well today. But then we could have malicious vendors in IoT space, which means every vendor today, I would say, they leave backdoors, if you agree or not. And there is no easy way to detect them, except you use open hardware and open source software. That's the only two ways, that we can defend against these big guys. Another thing is privacy. We never worked on privacy before. We did work last, I would say, 1 year or so. But the main reason was that the privacy is a prohibited world in industry because it limits innovations. But because of these new regulations, it's a law now to preserve privacy. I'll come back to this in a couple of slides as well. So very quickly, I think I am losing the time. The backbone of any security solution is the key. That key you use to protect your communication, your data, whatever. And in IoT world, there are three ways to manage or use keys. One is pre-shared keys, one is raw public key, and third one is certificates. The inherent limitation of pre-shared key is that both end knows the same keys. And you cannot make this system scalable up to billions of the devices unless you use some sort of trusted third party. And if you have a trusted third party, for example, in this case, it's called Trust Anchor, you share a single key with this anchor, and then every time if someone wants to talk to you, it comes through this anchor. This solution is now an Ericsson pattern. We work on this solution during this, and it's so amazing that you don't need to change any existing standard and you achieve scalability if you can afford to have a trusted third party always available. But as I said, the state of the art in the internet today is asymmetric cryptography, or something called PKI, public key infrastructure. And we rely on this heavily for all transactions we do on the internet. And one of the questions we asked ourselves 2 years ago, can we bring this into IoT world? And what are the limitations and how to use asymmetric cryptography with certificates and everything, the state of the art on the internet into IoT devices, which is also an internet of things. And luckily, or I would say consciously or deliberately, all standards, they specify that we can use asymmetric cryptography. So we are not the only ones who say that we should use asymmetric cryptography, but we are the ones who give the solution how to use this. These standards only specify that asymmetric cryptography could be used. So our solution will be standard compliant. We started a project called CBOT. It's called Certificate Enrollment in Billions of Things, and the main aim was to give identities to the IoT devices. Though it was a small project, we solved one basic problem, which is called enrollment. And enrollment is the process of certifying keys. If I have a key, how do I certify that belongs to me and I can use it? This is together with Nexus. I guess you know Nexus. This is the company which is behind this technology. They provide this behind this bank ID we use every day to log in to our banks and our websites, Workat and everything. So this is the main technology. Enabling technologies are from them. They are our really industrial partners. So they are the, I would say, most important PKI providers in Sweden. And we were happy that we teamed up with them. So what we do, it should be available in the offerings which our industry, Swedish industry, is offering to our communes and to the world as well. And this project was endorsed by many big players. You can see here. I'll skip this slide. This explains how we do this. But this is the output. What our industrial partners say about SICS and this project. That Swedish research project CBOT has solved one of the toughest IoT security problems, and it's not wrong to say this, because this enables you to use bank ID-like things, like your digital identity in a device. The strongest security you could have. It's a government-grade security we nowadays use based on PKI very quickly. And this is the Kentucky operating system. At SICS, we are mostly interested in resource-constrained sites. So everything I mentioned, it's implemented in the Kentucky operating system and released in open source. Very quickly, I'll take 1 more minute. I can see I'm very late. But this is something which is coming, and this is our bread and butter nowadays, and it should be your bread and butter nowadays. And it's extremely important to do this because it's mandated by law now. 2/3 IoT devices generate sensitive data. New regulations called GDPRs, they are coming May 25th, 2018. If you don't comply, you have to pay 4% of your global profit, or 20 million. These are the main pillars. But as a head of security lab, how do we ensure, how can we facilitate you through digital guarantees that your product services are GDPR enforced? We are not social scientists, so we are not going to give you some advice on this. But let's say privacy by design, how the technology can help you with this. And we are working on this. As I said, I just covered one small piece here. There's a lot more to do, and we have done a lot. There are a number of demos upstairs. You must go there and talk to the actual researchers, the people behind all these technologies. And thank you very much. And don't miss this as well.
Thank you very much, Shahid. You started up by saying that security is a showstopper. I don't agree. Do you agree?
Kind of.
You do? Okay.
But if you do the right technologies, I go back here. Cloud. You know, the enabler for IoT, for AI and deep learning and is cloud. You can do it because you have an enormous processing power offered by a cloud. But cloud is an external entity, and it's your personal data. You give your data to an external entity. How do you trust that cloud? And we are trying to solve this question, that you run your personal data in a cloud environment without trusting the cloud, and how you can do that. So, yes, I mean, it's a showstopper if you don't agree with me and don't use the technologies which somehow are there or being used. Of course, there's always a drift between security and convenience. And this will stay. I mean, it will never, you cannot not achieve 100% convenience with 100% security.
No.
Yeah. So the trade-off is important.
Yeah.
And definitely we are working on this as well.
Oh, that's great. And as you hear, you can, I think you have a lot more to say, so please grab Shahid also upstairs then later today. And now, Shahid, what kind of impact are you doing with?
The social impact.
Yeah, social impact.
This was red, I guess, the heart.
Oh, yeah.
Yes.
Yeah.
Okay, so then it's time to introduce, thank you, Shahid.
Thank
Thank
you.
you.